Hello. So today our topic is about Newton's law of cooling, and then this is one of the application of differential equation. So in this law, Newton's law of cooling, it states that the rate of change of the temperature of a body is proportional to the difference between the temperature of the body and the surrounding. So if we're going to analyze the law, this gives us the change of temperature over the change of time is equal to the proportionality constant K multiplied by the quantity T, which is the temperature of the body at any time, minus T sub S, the temperature of the surrounding, assuming that this temperature are constant. Solving this differential equation, this gives us the general solution P equals C E raised to KT plus DS. So this general solution will be used in order to solve some application. So given this example number 1, a metal bar at the temperature of 200 degrees Fahrenheit is placed in a room at a constant temperature of 20 degrees Fahrenheit. So if after 15 minutes the temperature of this bar is 50 degrees Fahrenheit, then let's find the temperature of the bar at any time t. And also, how long will it take for the bar to reach a temperature of 75 degrees Fahrenheit? So in this case, let's start to analyze first the given. So here it is stated that the temperature initially of the bar is 200 degree Fahrenheit. So let's we can say that this will be the T or T sub 0, first temperature, the initial temperature. Next, so after 15 minutes, so the temperature of the bar is 50 degree Fahrenheit. So this 15 equals 50 degree Fahrenheit. And now we need to find the time. The time where the bar reached a temperature of 75 degree Fahrenheit. The time at 75 degree Fahrenheit. So we will be using the equation here, the general solution, this one. So let me copy this first. So, additionally, it is stated in the given that there's the temperature of the surrounding is 20 degree Fahrenheit. So let's add it here. So we have Ts, T sub S equals 20 degree Fahrenheit. Going here at the general solution. So let's substitute the value of this temperature of the surrounding, and this will become just to replace this. Okay, this will be 20 degree Fahrenheit. So this value or this equation, so far this equation we will be using this. Okay, so let's find the temperature. Okay, temperature, the initial temperature after 15 minutes. Okay. So using this equation, okay, if we set our value here, temperature or the initial temperature is let's say it's 200 degree Fahrenheit, and since it is initial temperature, so the time here is 0. So if we plug in those values, so this will give us 200 degree Fahrenheit equals C E raised to K, proportionality constant, multiplied by time 0, okay, plus 20 degree Fahrenheit. Okay. So if we further evaluate this, we will get the value of constant C, and that is equivalent, or that is equal to 180. Then let's substitute the value of C in to the preceding equation, and then this will give us this will give us okay 180. So this will be our new formula. Using this formula, let's use this given, at time 15 minutes the temperature is 50 degree Fahrenheit. So if we substitute these values here, we have 50 degree here, 50 degree Fahrenheit, and then time is 15. Okay, we could get the value for K, the proportionality constant, and this K is equal to the ln of 30 over 180 all over 15. Let's further simplify. The answer is negative 0.1194. Okay. Next, so our new equation here will be this one. Okay, let's just substitute the value of p. We have here
Kala ko sir cake naman.
negative.
Oo, ako yung namin. Pero makikinig. Naghihilo po ako. Ay, tawa na tawa na rin.
Sabi mo sa sir, dyan ako yung ikakayat na din eh.
Ay, siya.
Okay, so this will be the new value or the new equation, and we will use it to calculate the time. Okay. To answer the letter B. So at time, or no, so given that the temperature here, okay, the temperature is 75 degree Fahrenheit, and then 70 degree Fahrenheit. So let's calculate, okay, the time, okay, for the bar, which is the 75 degree Fahrenheit. If you further evaluate this, the time here will be equal to 9.93 minutes. So this is the process, right, on how you get the time. Okay. Another example. So, second example. If the temperature of the air is 30 degrees Celsius and the substance cools from 100 degrees Celsius to 60 degrees Celsius in 25 minutes, find the time when the temperature will be 40 degrees Celsius. Let's analyze the given. So the temperature of the air or the surrounding temperature is equal to 30 degree Celsius, and then the initial temperature of the substance is, let's say it's T sub 0, is 100 degree Celsius. Then after 25 minutes, the temperature of this substance reduces, right? So it is equal to 60 degree Celsius. Now we need to find the temperature or the time when the temperature will be at 40 degrees Celsius. Okay. So at time, that will be the time at 40 degree Celsius. Again, using the general solution here, let's solve for this problem. We just simply substitute the value of our surrounding. So this will become okay. So we have this preceding. So this will be the new equation. Now let's use this to find the value of constant, or the arbitrary constant C. At initial time, like 0, at time 0, the temperature is 100 degree Celsius. So we just plug those values. We have 100 degree Celsius here, and then time 0. If you further evaluate this will give us C equals 70, and our new equation here will be as follow. This one. Now let's compute for the value of proportionality K. So at time 25, the temperature is 60. Time 25, that is 25 minutes. The temperature is 60 degree Celsius. So plug in those values. We have 60 degree Celsius here and 25 minutes. If you further evaluate this, the proportionality constant is equal to negative 0.03389, or let's round it off to 4 decimal, so this will become 9. And then substitute it to the preceding equation. We have here negative 0.0339, and then this one. Okay. This would be the new equation. Now let's use this equation to solve for the time where the substance is at 40 degrees Celsius. It's 40 degrees Celsius. Okay. Further evaluate, equate it to time t, and we obtain here ln of 10 over 70, okay, all over this proportionality constant, negative 0.0339, and the answer will be 7.4151 minute. So this is the final answer for this problem.